In this tutorial, we learn about the derivatives of exponential functions. And at the very end, I'll show you the most common mistakes students make when applying it, so you don't fall for them too. Whenever you see a variable in the exponent, like a to the power of x, we use the exponential rule to find its derivative. Let's break it down nice and clean. The rule says, if f of x equals a to the power of x, then f prime of x equals a to the power of x times the natural log of a. So we keep the exponential part exactly the same and just multiply by the natural log of the base. This works for any positive base a. Let's start with the most famous one. F of x equals e to the power x. When we apply the rule, the derivative is e to the power x times the natural log of e. But the natural log of e is just 1, so the final answer is simply e to the x. Next up, f of x equals 2 to the power of x. The derivative is 2 to the power of x times the natural log of 2. Similarly, for 10 to the power of x. We keep 10 to the power of x and multiply by the natural log of 10. See the pattern? We're always multiplying by the natural logarithm of the base. Alright, let's talk about how to differentiate exponential functions when the exponent itself is another function of x. Here's the general rule. The derivative of a to the power of g of x is a to the power of g of x times natural log of a times g prime of x. In math form, d by dx of a raised to the power g of x equals a raised to the power g of x times ln of a times g prime of x. So the key idea is differentiate the outer exponential first, then multiply by the derivative of the inside. Our first example is f of x equals e raised to the power of 3x cubed plus 5x. Step 1, we apply the rule. The derivative of f of x equals e raised to the power of 3x cubed plus 5x times the derivative of 3x cubed plus 5x. Step 2, let's differentiate the inside. The derivative of 3x cubed plus 5x is 9x squared plus 5. So the final answer is f prime of x equals e raised to the power of 3x cubed plus 5x times 9x squared plus 5. Next example. F of x equals 10 raised to the power of x squared plus 1. Step 1. Differentiate the outer exponential. F prime of x equals 10 raised to the power of x squared plus 1 times ln of 10 times the derivative of x squared plus 1. Step 2. The derivative of x squared plus 1 is 2x. Final result, f prime of x equals 10 raised to the power of x squared plus 1 times ln of 10 times 2x. So remember, with exponential functions where the exponent is a function of x, differentiate the exponential part first, then multiply by the derivative of the inside. This is a classic application of the chain rule, and it's one of the most common patterns you'll see. Alright, now let's look at a couple of very common mistakes students make when applying this rule. Mistake number 1. Treating exponential functions like power functions. For example, if f of x equals 2 to the power of x, some students write the derivative as x times 2 to the power of x minus 1. But that's wrong. Remember, that's the power rule, not the exponential rule. For exponential functions, we keep the exponential part and multiply by the natural log of the base. Mistake number 2. Forgetting the chain rule when the exponent isn't just x. Take f of x equals 2 to the power of 3x plus 2. A lot of students correctly multiply by the natural logarithm of 2, but stop there. They forget to multiply by the derivative of the inside, which is 3. So here's the takeaway. When you see a variable in the exponent, don't use the power rule. Always use the exponential rule, and if the exponent is more than just x, don't forget the chain rule. These two simple checks can help you avoid the most common exponential mistakes.